Hey guys, little enrichment time. Okay, so I'm not going to answer all these questions for you. Okay, I'm basically going to go over some of the new things that you haven't seen before. So looking at the graph above, this is a rational function. Okay, it has a hole in it, and this hole is located at 1, 3. Okay, so sometimes rational functions have holes. And how can you tell if a rational function has a hole? Well, here you can see it, okay, on the graph. In the equation, when there's a hole, it kind of looks like this. You're going to have A, which is going to be your horizontal asymptote, times x minus your x-intercept times x minus the whole. We'll talk about that, what that looks like in just a moment. Over x minus vertical asymptote times x minus the whole. Now notice these two factors are the same. Okay, so let's start off by building the equation. Okay, so it says A is the horizontal asymptote, and we'll talk about this later. Okay, so the horizontal asymptote's right here, and that value is 2. Okay, next, x minus our x-intercept. Okay, so looking back at our graph, we're going to have x minus our x-intercept is right here. It's where it crosses the x-axis. So it's going to be x minus -2 or x plus 2. Okay, then continuing to build our function, x minus the whole. Okay, so we're going to have x minus, and our whole is at 1. Take the x value, not the y value. Okay, x minus 1. Okay, on the bottom we have x minus the vertical asymptote. So x minus, and our vertical asymptote for this one is going to be right here. And that goes through -1. So x minus -1, which is going to be x plus 1. And then we have x minus our whole. So x minus our whole, which is 1. So you can tell when there's a hole when there's two factors that are the same. Okay, so we have a hole at 1. If you didn't see the graph, you would know there is a hole in this rational function at 1 because these two groups are the same. Okay, now to calculate that hole, right here, we want to calculate that. Well, it's pretty easy when you're given the graph. It's at 1, 3. Okay, another way to calculate the hole, let's say that you weren't given the graph and you were just given the equation, right? Well, we would know that the x-coordinate is 1. Okay, but to calculate the y-coordinate, we would have to substitute in 1. If we put 1 in, it's going to be undefined on the top and the bottom. So actually for this problem, we would need to get the whole information from the rational function, the graph. All right, y-intercept, you can do that. Yes, you can do that. This one does not exist. Yes, you can do that, you can do that, you can do that. All right, moving on. All right, so Now this one is unique rational function because it does not have a horizontal asymptote. It does have a vertical asymptote. And it has something called, and this author uses SA. And I'm thinking that they're calling this a slant asymptote. Let's go back to the front page real quick here. The slope of the slant asymptote. I like to call it the oblique. And I know the author of our textbook, which is about to change, uses the word oblique asymptote. Okay? And since it has a slope, it's going to be a slanted line. And I think that's why this author may use slant asymptote. Okay? All right, so back to this problem here. All right, let's start building. So A is going to be our horizontal asymptote, which it doesn't have, but it's the slope of our oblique asymptote. So in this case, looks like it's going to go right through. Let's see. It's going to go right through here. It's kind of eyeing it here. It looks like the slope is going to be 1 over 1. So our A value is going to be 1 times, okay, looking back, x minus our x-intercept. Well, in this case, we have two x-intercepts. So we have -2, so x plus 2, and x minus 2. Since there's two x-intercepts, we have to have two factors. And then we need our whole. And where is the whole? Here it is, which is at 4. So x minus 4. All right, over x minus our vertical asymptote, which in this case is 0. So x minus 0 times x minus the whole, which is at 4. Okay, so some of you may be asking, well, how did I come up with that slant? Well, I just kind of eyeballed it. Okay, for right now, we're just going to eyeball that slant. Okay, and so our whole is going to be at 4, 3. Okay, now we want to get, it does not have a horizontal, so that one is not there. And then for our slant asymptote, we want to have the equation of this line. So we know our slope is 1 over 1. So 1x, and the y-intercept is 0. So y equals x. And since our vertical asymptote is here, does it have a y-intercept? No. I think you can fill out the rest. All right, let's take a look at number 3. All right, this one's a silly looking one. Let's take a look a little bit closer at this one. Now, if you'll notice, okay, that this is curving, okay, like it's getting closer and closer to something, but it's flattening out. And the same thing on this side, it's kind of flattening out here. So it does have a horizontal asymptote. Remember what I told you. Graphs can cross horizontal asymptotes, never vertical asymptotes. Okay? So I eyeballed it. I kind of look like it's getting really close to it, so I'm going to go here with -3. So starting off with our A value, which is -3, times x minus our x-intercept. So we have x plus 3 Other x-intercept is 2, so x minus 2. Okay, over x minus our vertical asymptote, which is at -1 here, as you can see. You can find those asymptotes when you have two parts of the graph that's approaching, flattening out, if you will. So x minus -1. And the hole, is there a hole? I don't see a hole. Now we got to get the other vertical asymptote here, because this one is approaching something and this one is approaching something. So 4, 5, I'm going to guess 6. Yeah, that seems about right. So x, so we have two vertical asymptotes, so x plus 1, x minus -1, which is x plus 1, and x minus 6. No holes? Okay, so there's your equation. So this one does not have a slant asymptote or oblique, none. It doesn't have any holes, none. And domain, we'll do the domain just for fun. X cannot be -1. X cannot be 6. Range goes up infinitely, goes down infinitely. So all real numbers. Vertical asymptote goes with domain. Horizontal asymptote, y equals -3. X-intercepts, -3, 0, 2, 0. Y-intercept, right here, 0, -3. There you go. Have fun. Remember, it's due on Friday. Sooner the better, though.